we should talk about number 21. So the idea of this problem is simple. Find the volume of a cube. So the volume for a cube is, of course, the side length cubed. Simple formula. So it should be a simple problem, right? Well, that depends on how comfortable you are dealing with square roots. So let's start just by plugging in the side length that we have. The side length would be 4 times the square root of 3 meters. We're going to plug that into our formula, and let's just see what we get. So the volume equals something cubed, and that something is 4 square root of 3. Okay, that seems easy enough. Now we need to simplify our answer. So remember, anytime you cube something, regardless of what it is that you're cubing means you take it and you multiply it by itself 3 times. Okay, so let's think about how this is going to work. To do that, down here at the bottom, I'm just gonna write out a very similar situation in which you would probably know what to do when you got to this step. So what if instead of 4 times square root of 3 cubed, I had 4 times something else? Let's call it x. What is this x? It could be anything. It could even be the square root of 3. So we're going to multiply 4x times 4x times 4x. So you might know what to do here. You would multiply the 4 times the 4 times the 4. In other words, you would cube the 4, and that would give you 64. You might even remember what to do with the x's. You would take x times x times x, or in other words, x cubed. The same thing works here. So just pretend this square root of 3 is like your x. We're going to multiply the whole numbers together, 4 times 4 times 4, and get 64. But then we've got the square root of 3 cubed. So how do we deal with that? So I've got the 4's multiplied together. So here are the square roots of 3 left that I need to multiply together. The square root of 3 cubed. This is like my x cubed down here. And so how do I do that? Well, you might think that the cube and the square root are going to cancel each other out, but that's not exactly true. So let's just take these 2 at a time. We'll multiply them together, just like we might with the 4's. You might say 4 times 4 is 16. Okay, then take that 16 and multiply it by 4. There's 64. Let's try that same logic with the square root of 3's. So what's the square root of 3 times the square root of 3? So the square root of 3 squared, in other words, times itself twice. Well, it's the square root of 9, or simply 3. The square root of 3 times the square root of 3 is 3. And then, if I multiply that 3 by another square root of 3, there's not a second square root for this square root to cancel out with. In other words, this one doesn't get squared. The square root is not going to cancel. So we have a leftover square root of 3 on the end there. So 3 times the square root of 3. That's what we get when we multiply these 3 square roots together. 2 of them combine to make a 3. And then we have one sad and lonely leftover square root of 3 over here. So then it's 64 times 3 square root of 3. And again, we can look at this as 64 times 3x, something like that, some similar situation. What would you do in that situation? You would multiply the 64 and the 3 and leave the x off to the side. Same thing we do here. 64 times 3, let's see, 60 times 3 would be 180. 4 times 3 would be 12. Add those together, 180 and 12, that's 192. So 192 times the square root of 3. And that is the exact answer. So if the problem asks you for an exact answer, you would just leave it in simplified, but leave it in this form with the irrational number, the square root of 3, written off to the side, kind of like you might do with a pi, another irrational number. If you type this in your calculator, it's going to give you a decimal which will inevitably be rounded, which would be an inexact answer by definition. So the exact answer would be written like this. If you wanted it rounded to the nearest tenth, that's the only reason you would plug this whole thing into your calculator. Oh, and before I forget, that should be in meters cubed, because it's a volume.